In this video, we're going to take a look at the half-angle identities. Before we just list out what those half-angle identities are, let's try deriving them with the information that we already know. To develop the half-angle identities, we're first going to develop new identities for sine squared, cosine squared, and tangent squared. And we're going to make use of some of these identities for double angles that we've already determined. So let's start with the half angle identity for sine. We know that the cosine of 2 theta is equal to 1 minus 2 times sine squared theta. Now, why are we talking about the cosine of 2 theta when we want to find the half angle identity for sine? Well, that's because in this version of the double angle for cosine, we have a sine in that, okay? So I'm going to use that, and I'm going to rearrange this identity so that it is equal to sine squared theta. I'm going to, let's see, maybe add 2 sine squared theta to each side, and then subtract cosine of 2 theta from each side. So I'm just going to rearrange stuff, make sure that you follow it. I'm going to get 2 sine squared theta is equal to 1 minus cosine of 2 theta. Okay, so I just moved this 2 sine squared theta to the left, and I moved the cosine of 2 theta over to the right. All right, now I'm going to divide each one of these sides by 2. I want to get that sine squared theta by itself. So here's what that gets me. That gets me sine squared theta is equal to 1 minus cosine of 2 theta all over 2. Now don't think that you can take that 2 in the denominator and cancel it with this 2 that's trapped inside that cosine. You cannot. It is trapped. It's part of the argument of the function. If that 2 were on the outside of the cosine, then yes, you could. But in this case, no, you can't. All right, now here's where it gets a little bit tricky. I'm going to let theta equal a half angle, right? This is where I bring in the half angle idea. So I'm going to let theta equal some other angle, call it alpha, over 2. And I'm going to substitute. So now what I'm going to have is sine squared of alpha over 2, right? I'm just substituting in. And that's going to equal 1 minus the cosine of 2 theta. Remember, theta, we just said, was alpha over 2, all over 2. Now, let me simplify this just a little bit. That's going to give me 1 minus the cosine of, notice that this is 2 over 1, that, and I know it's a little bit messy, so I apologize for that, but the 2 up here in the numerator and the 2 down here in the denominator are going to cancel, and so I'm just going to be left with alpha on the inside, all over 2. Now that's what sine squared of the half angle equals. I want to know what the sine of the half angle equals. So what am I going to do? I'm going to square root each side, and I'm going to be left with plus or minus the square root. I'm going to take the square root of this whole thing, 1 minus cosine of alpha all over 2. And that is the half angle identity for sine. Now, let's do the same thing for the half angle identity for cosine. Again, you're going to see me start out with the identity for the double angle for cosine, but this time, because I'm looking for cosine, I am going to use the identity for the double angle that involves cosine, okay? And I'm going to do the same process of trying to isolate that cosine squared. So in this case, I think that I will add 1 to each side. I think that'll do it. So that'll give me cosine of 2 theta plus 1 equals 2 cosine squared theta. And I'm going to divide each side by 2, just like you saw me do before. I'm going to divide each side by 2. And so let me just rewrite here what I've got. So I'm going to reverse the sides here, right? So I'm going to have cosine squared theta is equal to cosine of 2 theta plus 1 over 2. A lot of just algebra, right? Moving stuff around. Now I'm at the point that I was with sine squared, and I'm going to do the same process. I'm going to continue to let theta equal some other angle, and I'm going to let theta equal alpha over 2. Nothing wrong with me doing that because they're just variables, right? Theta and alpha are just variables. So now I'm going to substitute those variables. So in the place of this theta, I'm going to write cosine squared of alpha over 2. That's going to equal the cosine of 2 times alpha over 2 plus 1 all over 2. And just like we saw before, inside the argument of the cosine, the 2's are going to cancel. And so I'm going to be left with cosine squared of alpha over 2 is equal to the cosine of alpha plus 1 all over 2. I want to know what cosine of the half angle is equal to. So to get rid of the square, I'm going to square root both sides, and I'm going to be left with plus or minus the square root of this whole thing, the cosine of alpha plus 1 all over 2. That is the half angle identity for cosine. Now, what about tangent? In order to do tangent, I also want to think about tangent squared, right? That's how I approached finding the half angle identity for sine, right? I isolated for sine squared. Half angle identity for cosine, I identified, or I isolated cosine squared. So I want to know something about tangent squared here. And what I know about tangent squared is that it is equal to sine squared over cosine squared, right? That's true. We've seen that many, many times. So now using the identities that I just found, right? So what do we know about sine squared theta? We know that sine squared theta, maybe I'll just highlight this for you. Sine squared theta, we found out in our calculations that sine squared theta is equal to, so I'm going to have up in the numerator here, I'm going to have that's equal to 1 minus cosine of 2 theta all over 2, and that's going to be over, right? So that's what sine squared is. What does cosine squared theta equal? Cosine squared theta we calculated was cosine of 2 theta plus 1 all over 2. So let's see here. That's going to be cosine of 2 theta plus 1 all over 2. And I hope that you see here that those 2's are going to cancel. And so I am left with 1 minus cosine of 2 theta over cosine of 2 theta plus 1. Cosine of 2 theta plus 1. Now I'm going to do the same process that you saw me do before. I'm going to continue with this idea that theta, I'm going to let theta equal alpha over 2. And so I'm going to say, instead of writing tangent squared theta, I'm going to write tangent squared of alpha over 2. And that's going to equal 1 minus the cosine of 2 times alpha over 2 all over the cosine of 2 times alpha over 2 plus 1. Really easy to get lost in this, right? But I think we've got this. So inside the argument of the cosine, the 2's are going to cancel in the numerator and in the denominator. And so I am left with 1 minus the cosine of alpha all over the cosine of alpha plus 1. That's what tangent squared of the half angle equals. If I want to find out what the tangent is of the half angle, then I simply need to square root, right? So I'm going to write plus or minus, and I'm going to square root all of that. And that is my half angle identity for the tangent. So here's a summary of what we just derived. The half-angle identity for sine says that the sine of some angle, in this case alpha, over 2 is equal to plus or minus the square root of, in the numerator, 1 minus the cosine of that angle all over 2. For the cosine of alpha over 2, that's equal to plus or minus the square root of, in the numerator, 1 plus the cosine of alpha all over 2. The half-angle identity for tangent says that the tangent of some angle alpha over 2 is equal to plus or minus the square root of, in the numerator, 1 minus the cosine of alpha over, in the denominator, 1 plus the cosine of alpha. Now, you'll notice that there's some space under there because there are some variations of that tangent half-angle identity. If you were to do something like manipulation of this where you multiply by conjugates, you could rewrite the tangent of some angle alpha over 2 as being equal to 1 minus the cosine of alpha all over the sine of alpha. Or you could even do another variation where the half angle for tangent is equal to the sine of alpha over 1 plus the cosine of alpha. Again, that comes from algebraic manipulation involving multiplication by the conjugates of either the numerator or the denominator. And I'll leave that proof up to you if you want to do it, but just know that you may see in books or in notes any 3 of these half-angle identities. All right, let's try an example. And in this example, it's actually a continuation of an example that we did earlier. We are given that the cosine of theta is equal to negative 2/5. I'm just going to highlight that because I think that's going to be useful to us here in just a second. We're also told that theta is equal, or not is equal, but is between pi and 3 pi over 2. So we knew that theta was in the third quadrant. And what we were asked to do earlier was to find the double angle, so the sine of 2 theta and the cosine of 2 theta. Now we want to find out the half angles, both the sine and the cosine. So we're going to have to make use of the identities that we just derived, okay? Now notice in the identities that we derived that our angle placeholder was alpha. We now are dealing with theta, so everything changes to a theta. So let me write this out. So I'm going to say that the sine of the angle theta divided by 2 is going to equal plus or minus the square root of 1 minus the cosine of theta. Now what is the cosine of theta? I highlighted it for you. That was given to us as negative 2/5 all over 2. Okay, so 1 minus a negative, right? That's minusing a negative is the same thing as adding the positive. And we can think of 1 as 5 over 5. So 5 over 5 plus 2 over 5 is 7 over 5, right? 7 over 5. And I'm dividing that by 2 over 1, which is the same thing as multiplying by 1 over 2, isn't it? So I'm going to get, let's see, plus or minus, looks like the square root of 7 in the numerator and square root of 10 in the denominator. Now, I think that you should always rationalize the denominator. Some books might tell you differently, but it's not going to hurt you to rationalize the denominator. So I'm going to multiply that denominator by square root of 10, which means I need to do that up in the numerator as well. So I'm going to get, up in the numerator, I'm going to get square root of 7 times the square root of 10, which is the square root of 70, over square root of 10 times square root of 10 is 10. Now, I have to determine, is it the plus or is it the minus version, right? Because it says plus or minus. Which one is it? Now, you might be thinking to yourself, oh, well, we're talking about the sine, and we are in quadrant 3, so the sine is negative in quadrant 3, so this must be a negative. However, we know that theta is in quadrant 3. Just imagine some angle that's in quadrant 3. If you then take half of that angle, it moves into a different quadrant, doesn't it? Right? So just think about this for a second. What if you had, and I'll just do this over on the side. Let's just say that theta is equal to, I don't know, 300 degrees, right? Oops, that's not in the third quadrant, is it? What's in the third quadrant? How about 200 degrees? That's what I was thinking. Theta is equal to 200 degrees, right? That's a third quadrant angle. If I take half of that angle, now I'm at 100 degrees. Okay, 200 degrees was in quadrant 3, but 100 degrees is in quadrant 2, right? So now if we're talking about sine, the sine of a quadrant 3 angle is negative, but the sine of a quadrant 2 angle is going to be positive. So it changes things. Another way to think of that is if it's being given to you. So that's just a way to think about it. But if you are being given that pi is less than theta is less than 3 pi over 2, but you want to know something about theta over 2. So let me just write this out. So you want to know something about theta over 2. Well, if you divide that theta by 2, then you also have to divide the pi by 2 and the 3 pi over 2 by 2. Did you get that? So that becomes, let's see here, that becomes theta over 2 is going to be between pi over 2 and 3 pi over 4. Okay, so imagine on a circle, pi over 2, we know is straight up on the positive y-axis at 90 degrees into 3 pi over 4. So that is definitely quadrant 2, isn't it? And in quadrant 2, the sign is positive. So the sine of theta over 2 is going to be positive square root of 70 over 10. And, you might even make yourself a note to say, well, in quadrant 2, I know that the cosine is negative and I know that the sine is positive. So already, even though I don't know part D, which is what the cosine of theta over 2 is, I already know, if I'm thinking ahead, that whatever that answer is, that it's going to be a minus, right? When my option is plus or minus for this particular problem, it is going to be the minus version. All right, so let's go ahead and do this. So we're going to have cosine of theta over 2. That is going to equal, I'll go ahead and put the plus or minus in there and then put the correct symbol at the very end. So I'm going to have 1 plus the cosine of theta, and remember that was given to us as negative 2/5 all over 2. Okay, so that is plus or minus the square root of, we can think of 1 as 5 over 5, so 5 over 5 plus negative 2 over 5 is 3 over 5. And again, instead of dividing by 2 over 1, I'll multiply by 1 over 2. And so that's going to get me plus or minus the square root of 3 over the square root of 10. I'm going to rationalize that denominator again, because I need to in this case. And I'm left with the square root of 30 over 10. Square root of 30 over 10. And because that half angle has moved to the second quadrant, and I'm talking about the cosine, in the second quadrant, cosine is negative. So that is my final answer.